So to complete the explanation here of segmentation and its function, it's the back and forth movement of the food bolus, food item, and in doing so, breaking it up, segmenting it, and in doing so, increasing surface area for access by the enzymes to more efficiently break down, chemically digest the food, and to mix things up. And this is what's occurring in the small intestine. Okay, so let's get on to membranes. So the peritoneum, the serous membrane of your abdominal cavity, abdominal pelvic area. You remember membranes have two layers. There's the parietal and the visceral layer. So the parietal peritoneum lines the inside surface area or inside surface of the body, and that's here color-coded in red for you. Oops. The visceral peritoneum, remember visceral is innermost because the way to remember that is your visceral organs are inside, so the visceral peritoneum covers the surface of the internal organs, color-coded here in blue. And then the peritoneal cavity is greatly exaggerated here, but it is a cavity that's filled with fluid that allows for some movement of these organs, but yet the organs are held in place by these tissues, these mesenteries, as we'll see and learn a few of them. So the peritoneal cavity, again, fluid filled, allow for movement and helps reduce friction, just the way the pleura and the pericardial sac, pericardium, help reduce friction as the lungs move and the heart moves. So the mesenteries, these are extensions of the parietal peritoneum, and they help tether and anchor and support the digestive organs within the abdominal pelvic cavity. So one of them is the greater omentum, and it's from the greater curvature of the stomach here. That's the stomach, liver, stomach, and it flops down over, drapes down, and then comes back up, and then it's attached to the transverse colon, the part of the large intestine that kind of cuts across diagonally from left to right in the pelvic abdominal area, and loosely draped over and covers the intestines. So there would be the greater omentum there. Excuse me. The mesentery proper runs from the small intestine, and it anchors it to the posterior wall. So here's the convolutions of the small intestine, and there's the mesentery proper. It has numerous extensions, and it helps hold and tether the small intestines to the posterior wall of the abdominal cavity. There, here, okay. Small intestines, mesentery proper. So here's a dissection of a cadaver. Sorry, there's the liver, portion of the stomach, and this is the greater omentum, which is draped over the small intestines, covering them like a flap, and has some fat material stored on it. And if you were to flop this upwards, you would expose the small intestines. So there's the greater omentum. Okay. So those are the only ones you'll need to know by name. Okay, let's move on to the oral cavity. Functions: ingestion of food, tasting of the food. Remember the taste buds. Lubrication in the sense of releasing mucus and saliva. Mechanical and chemical digestion. So mechanical, the chewing of the food, moving it around with the tongue. And then the chemical digestion begins in the mouth and the oral cavity because of the salivary amylase and lipase that are produced. So ASE endings for enzymes. Amylase starts the digestion, chemical digestion of carbohydrates, and lipase for lipid, the chemical digestion of fats, lipids those two food products are the first ones, well, they first start getting digested in the oral cavity by the action of amylase and lipase. Okay. The epithelial lining in the mouth, oral cavity, is non-keratinized, meaning it's moist, wet. Stratified squamous epithelium, remember epithelia in our tissues? Stratified squamous because our oral cavity has to deal with a fair amount of abrasion. Some of the food that we ingest and start to digest, chew up, and then chemically digest is pretty abrasive. Think of eating potato chips or tortilla chips. Okay? So to deal with that abuse and abrasiveness, your mouth is lined with non-keratinized stratified squamous epithelium. Your cheeks help in the chewing process, mastication process, because of the buccinator muscle that helps keep the cheeks closer to the teeth. So as you chew, the buccinator muscles in the cheeks help keep the food in line with the teeth for mastication. The lips help cover and keep the mouth closed when you're chewing, and they fit over the teeth. The gingivae are your gums. So if you ever heard of gingivitis, that's swelling and bleeding of the gums. The hard palate, the roof of the oral cavity, and it separates the oral cavity from the superior nasal cavity. If you remember, it's formed in part by the maxilla and the palatine bone. The soft palate is posterior to the hard palate. It's just some muscle and connective tissue, epithelium, and the part that hangs down, that little thing there, is the uvula. When you swallow, the function of the soft palate and the uvula is to kind of move upwards a bit and close off the opening to the nasal cavity, so that when you swallow, food goes back posteriorly and then is pushed down inferiorly into the esophagus once it passes the pharynx. And we'll talk about the regions of the pharynx soon. The tongue. Skeletal muscle, it's under conscious control. It's involved with the mechanical digestion of food, handling food, moving it around, pushing it towards the teeth. Manipulation of food, handling. Sensory analysis of the food, texture, even temperature. Produces mucin, which when it gets wet is mucus. And lingual lipase for the chemical digestion of lipids and fats. And also involved in speech production. When you speak, your tongue moves around to help you pronounce sounds and words. Remember the papillae and the association with the taste buds. So the papillae provide some frictional ability to the tongue, but also housing the taste buds for taste sensation. Salivary glands, 3 pairs, producing saliva, which is very watery, to help moisten and lubricate the food so that when you swallow a nice, moist, pasty bolus. Also producing a salivary amylase for starch digestion again. We have the parotid salivary gland, just anterior and slightly inferior to the ear. We have the sublingual gland below the tongue, hence sublingual. And then some submandibular gland just inferior to the mandible, at least part of the mandible, hence the name submandibular gland. And they all have their little ducts to empty saliva into the oral cavity. All right, the teeth. So biting, mastication of food, and tearing of food. These are real teeth, by the way, on a real skull. The anatomy of a tooth. The crown is the exposed portion of the tooth that you can see. The neck is the somewhat of a constriction part of the tooth that comes into contact with the gingiva, the gum line. And then the part that extends down into the mandible or the maxilla is the root or the roots of the tooth, or of a tooth. The material of the crown is enamel, primarily calcium phosphate. So the material is the enamel, and that's the hardest material in the human body. The inner part of the tooth, which is in brown here, is another material referred to as dentine, or dentine, which is very bone-like. And then covering the roots, or root, is cement, which helps anchor the tooth to the tethering periodontal ligament, which is kind of in blue here. The periodontal ligament helps hold the teeth in the sockets. Okay. So internally, you have the pulp cavity, which is filled with pulp, which is blood vessels and nerves. And then the pulp cavity that extends into the roots is the root canal. Okay? And at the bottom of the root is the opening, apical foramen, through which the blood vessels and nerves enter into the teeth. What else? That's enough. Okay. Well, that's the apical foramen for entry of the blood vessels and innervation, nerves. And then the sockets are the teeth alveoli. So you can't see the alveoli unless the tooth has been removed, and then the space in the bone is the alveoli, or the socket. And again, the gingivae are the gums. Gingiva is singular. Okay, your different types of teeth. We are referred to as being heterodont, meaning our teeth are not all the same. Different shapes different shapes and different functions. Okay, so your deciduous baby teeth or primary teeth, we had 20 of them, most of us. They fall out and they're replaced by your permanent adult teeth, 32 in total. 4 of them are the wisdom teeth, the third molars. Some of us still have them. Some of us have had them removed. Incisors at the very front are for clipping and biting off food. Okay. And then canines. Oh, so the 2 and the 8 is in the upper jaw. You have 2 on one side, so then 2 on the other side, and then lower jaw you have 2 on one side and 2 on the other side, total of 8. So the canines, or cuspids, on each half of a jaw we have 1 each. There you go. So a total of 4 canines or cuspids. Called canines, think of a canid or a dog, a canine. They have elongated ones, or like your cat, nice and long and sharp. Your cat is a strict vegetarian. Dogs are often considered omnivores. Whoa, your cat is a strict carnivore. I'm sorry, I got that wrong. That means they eat only meat. And dogs are usually considered carnivores, sometimes omnivores. But something like us, our human animal, we still have canines, which indicates we should still have some meat in our diet. But our canines are not very long or pointy, which indicates that this animal, the human animal, should eat meat, but it should not be the major portion of our diet. It should just be almost a luxury item in a way. Our dentition, our teeth, tell us we should eat primarily fruits and vegetables and plant material.